Well, this is a bit of an experiment, but I'm going to go with it. Probably not going to work as well as I hoping it would, but it'll be what it will be. So, good morning, folks. Actually, hold on. Good morning, folks. Going to be trying something to see what happens, what works, and the like. But today we're going to be looking at key topics of probabilities. And depending on the context, whether it's for a statistics class, for general life, for helping make sense of the world around us, or preparing to teach others, the idea set based by probabilities is a very broad and can be pretty important one. So one key initial idea that goes along with probability is that a probability experiment is an action or trial through which specific results, such as counts, measurements, or responses, are obtained. The results of any single trial in a probability experiment is called an outcome. So when dealing with probabilities, we are dealing with events that we don't know and can't reasonably predict the way that they will come out. That doesn't mean there's unlimited options. All it means is that we don't know what the outcome is going to be at the time the event occurs. Any probability will fall between 0 and 1. So the probability that some event E will occur is between 0 and 1 inclusive. So the probability is always 0 equal to our probability less than or equal to 1. But this brings up the question, so what is an event? Well, an event is a portion of our sample space. Okay, what's a sample space? A sample space is a set of all possible outcomes of a probability experiment. So a sample space is anything that can happen in a probability experiment, whereas an event is some grouping of those that carry with us one or more of our outcomes. So a deck of cards can be viewed as a sample space and often is. It is made up of 52 unique possible outcomes. If we pick a card, any card, you can get any of these 52 outcomes. But if we want to pick an ace, then there are 4 possible ways that we can arrive at that. If we want to pick a face card, there are 12 ways we can get one. A number card, there are 40 ways that can happen, or 36, depending on whether you count aces as numbers or not. We also have sample spaces related to dice, where we have any number between 1 and 6. A simple event is an event that consists of a single outcome, where a compound event is an event that consists of multiple possible outcomes. So if I roll one die and I'm looking for a 2, then the only event that I care about is landing with a 2 up. If I roll a pair of die and looking for any arrangement of our die that includes a pair of 2, or that includes a 2, then that would be a compound event. There are 3 broad approaches or ways to think of probabilities. Classical is or theoretical probability is used when each outcome in a sample space is equally likely to occur, and the classical probability in an event, E, is given by the number of outcomes in an event, E, and over the number of outcomes in a sample space. So the number of outcomes in event E over the number of outcomes in a sample space. In the dice game craps, you're rolling 2 die. And you can have any pair of numbers. You can have 1 and 1, 1 and 2, 1 and 3, 1 and 4, so on. And there are a total of 36 different ways that those numbers can pair up. However, just because there are 36 different ways that we can get our pairs, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, where we have this variety of ways that our die can land. What is more important in that isn't the numbers on the die, but it is in some ways the total that you get from your pairs of die. So snake eyes, or a pair of ones, give us a total of 2. There's only one way for that to happen. But if we have a 2 and a 1 or a 1 and a 2 adding up to 3, that can happen in two different ways. So when we have our total number of points, or total number of pips given to us in green, and we range from 2 to 12 as our totals. 2 and 12 can only occur one way each. 3 and 11 can be arrived at two ways. 4 and 10, three ways. 5 and 9 can only occur, or can each occur four ways. 6 and 8 can occur in five ways, and the total of 7 can occur in 6 different ways. So our totals of 7 are far more likely than our totals of 1 or 12. Each pair of numbers is equally likely. The different sums of our numbers are not. Classical probability goes into figuring out the probabilities in games of chance and casino games and things like that. But it is only semi-useful in our daily world. The two other types of probability that we are going to deal with much more often are our subjective probability, which is a non-mathematical probability because there's no real formula that we can just drop numbers and stuff into to crank out a probability value. It is based on experience, intuition, guesses, estimates. And we use it when we determine, will this lunch end up with me getting covered in debris and stains before my business meeting? Will this outfit draw the attention of the right people? Will this outfit let me hide and be ignored by others? Will this roadway be the most efficient and effective way for me to get from point A to point B? And so on. There are a lot of different options of how we can view subjective probability. Almost everything we do on a daily basis involves that. When we're dealing with statistics in general and many other things, we're actually going to be using empirical probability or statistical probability, which is based on observations obtained by probability experiments. The empirical probability of an event E is the relative frequency of event E, or the frequency of event E divided by the total frequency. So the frequency of the event divided by the size of the number of attempts. when you actually roll a die or a pair of die, theoretically, they will end up in or 6 ways for one die, 36 ways for two die over the course of numbers that are much larger than those, multiples of 6 or 36, and arrive in the proper proportions. However, that doesn't happen in general. And when you have a low number of multiples of your die rolls, you end up with a set of ratios that are askance or out of line with what you theoretically they should be. Somewhat more importantly, you get things such as the probability of an individual having a particular disease, or the number of red cars in the parking lot. You're not going to know in advance how many cars are in the parking lot. There's no way to control that. You're not going to know how many of them are red. You have no control over that until you just go and take a look. You don't know how many people you're going to be able to analyze for a particular disease and whether you will be getting or what numbers you'll be getting anyway. However, particularly with things based on probabilities where the structure of the game or event allows for some predictions in our classical sense, as the number of trials goes up, we will be getting closer and closer to our theoretical match based on our law of large numbers. As you increase the number of times a probability experiment is repeated, the empirical probability or relative frequency of an event approaches the theoretical probability of the event. So the more and more times you run an event, the more likely it is that you'll come into alignment with the event. I should note that many of my definitions come out of this textbook, Elementary Statistics, Picturing the World by Larson and Farber. I think it's the 2017 7th edition. Okay. Since an event either can or cannot happen, or has not happened, then we have what we call the complement of an event. So it is the set of all outcomes in a sample that are not included in event E. The complement of event E is denoted E prime. So the event or the probability of event E is 1 minus the probability of E prime. So the probability of the complement of E is 1 minus the probability of E of our event. So you commute to and from work or school, and the probability that you will get there safely each time is pretty good. But there's also a probability that something will go wrong. Either you'll blow a tire, you'll run out of gas, you'll have other car trouble, you'll hit something, someone will hit you. Things happen when you're on the road. As such, there is going to be a probability that you do not arrive safely. That is given to us by our complement. So if you have a 95% chance of arriving safely, that means you have a 5% chance of not arriving safely. We have any of our probabilities of an event range from 0 probability to a probability of 1 or 100%. An event that has 0% chance of occurring is an impossible event. And an event that has 100% chance of occurring is a certain event. Anything in between is varying degrees of unlikely to likely. In many areas of statistics, a 5% rule is applied. Anything that has less than a 5% chance of happening at random is considered to be statistically relevant or irrelevant, depending on the particular circumstances. Anything with more than that is treated accordingly. Determining the cardinality or the number of elements in a group or a set is one version of counting, but in a grander scheme of things, the fundamental counting principle states that if an event can occur in m ways, and a second event can occur in n ways, then the number of ways the two events can occur in sequence is m times n. This can be extended to as many different elements as we would like. So we have m different meats. Let's say we have 7 meat options or meatless options, depending on what you prefer. We have our bread options, and we'll have 6 of those. Cheese options, including no cheese at all. We're going to have 8 of those. And our first choice of veggie, we will have 10 of those. So we have 7 types of meat options, or 7 options in our meats, 6 options in our breads, 8 options in our cheeses, and 10 veggie options. In order to figure out how many total arrangements of sandwiches we can make from these, we're going to multiply 7 times 6, get 42. 8 times 10 will give us 80. Then we'll multiply 42 and 80. and we get 3,360 different sandwiches, which means you can do lunch from there every work day for more than a decade, and you will not have to repeat. Okay, and I will try to post a separate video talking about other elements of probability in a little while, but I'm going to stop at this point.